All right, AP, let's work on a sample problem doing temperature conversions. Normal body temperature is 98.6 degrees Fahrenheit. Convert this temperature to the Celsius and Kelvin scales. Go ahead and do these calculations on your own. Press pause if you need to, because here comes the solution. When push comes to shove, I hope you guys can simply bust out some equation to make this a little bit easier and time saving for you. But instead of doing that right now, let's just think it through. Okay, we can be plugging this stuff into equations later. So first, we want to convert 98.6 degrees Fahrenheit to the Celsius scale. The number of Fahrenheit degrees between 32.0 degrees Fahrenheit and 98.6 degrees Fahrenheit is 66.6 degrees Fahrenheit. Again, that's the difference between the freezing point, okay, established by the freezing of water, and this normal temperature that we're looking at. The difference there is 66.6 degrees Fahrenheit. Now, if we were simply going to convert this into Celsius using an equation, which I hope you can do, I hope you end up being able to do, because it's a lot more time efficient. Okay, you don't have to bother thinking through this down the line. You can save those, that brain energy for something else. But you would simply use a conversion factor. Use the conversion factor in the exact same way that we've worked out before. Now, through your reading, you should see that the conversion I'd use here is things that are equal. 5 degrees Celsius is the same as 9 degrees Fahrenheit. So that's your statement of equality. So I can make a conversion factor out of this statement of equivalency. I'm going to put the degrees Fahrenheit on the denominator so that the degrees Fahrenheit cancel out. I am in degrees Celsius, and I get 37.0 degrees Celsius. Again, using the 66.6 to tell me that there are 3 significant figures I need to report in my answer. But let's look at this diagram. Let's try to understand this conceptually here. So we have, and again, this picture here is from your text. So this isn't, I'm not pulling any punches here. So we have Fahrenheit, Celsius, Kelvin. So this normal temperature here is 98.6 degrees Fahrenheit. Freezing point, which is 32 degrees Fahrenheit, it's also 0 degrees Celsius and 273.15 Kelvin. Okay, so these represent the exact same temperature right here. We are trying to find what this 98.6 degrees Fahrenheit is in Celsius and in Kelvin, and we're going to use this common temperature to help us do that. So if there's a difference between 98.6 degrees Fahrenheit and 32, like we already said, it's 66.6 degrees Fahrenheit. The difference between this 0 degrees Celsius and whatever this temperature is here is still going to be the 66.6 degrees Fahrenheit, but in Celsius, that's going to be the 37.0 degrees Celsius. Now that we have the degrees Celsius, we can use that to help us understand what this degrees Kelvin is going to be. Now, from your reading, you should know that the Kelvin scale is based on absolute zero. It's very useful in gases in the kinetic molecular theory of motion because it describes molecular motion. So 0 degrees Celsius is the exact same as 273.15 Kelvin because, again, I mean, the water's frozen, but there's still quite a bit of molecular motion going on there. However, 1 degree Celsius is the exact same thing as 1 Kelvin. Okay, those are the exact same thing. And so to get up to the freezing point, we're simply going to add 273.15. And if I know what the degrees Celsius are for any particular temperature, let's say 37.0, hint, hint, all I have to do is add the 273.15 Kelvin to that number. Again, I'm getting it from here. And that's going to be the temperature in Kelvin, 310.2 Kelvin. And again, just a friendly reminder, you do not say degrees Kelvin. You simply say Kelvin. 310.2 Kelvin. Thus, 98.6 degrees Fahrenheit corresponds to 37.0 degrees Celsius. Now that we know what that degrees Celsius is, we can convert to the Kelvin scale, because again, you have to have the Celsius value in order to get to Kelvin, because any temperature Kelvin is equal to temperature Celsius plus the 273.15. Okay, so what that ends up looking like is the 37.0 plus 273.15. That's your 310.2 Kelvin. And note that the final answer has only one decimal place because the 37.0 is the limiting factor there. Again, get in the habit of always asking, okay, here's my answer. Are the significant figures right?